In this video, we're going to look at what happens if I want to take a line and I want to cut it into a specific ratio, such as a 1:2 ratio, which would give me 1/3 of the line, instead of what we did in the previous video, which was just to cut the line in half or find its midpoint. Well, to do that, we have to look at something called partitioning a line segment. And so that's basically what we're going to be doing here. Is we're going to be taking a line segment and we're going to break it into a certain number of pieces. We're going to find the point that then breaks it into that number of pieces. To do that, we get this formula here that's going to be equal to some point x comma y that partitions a line segment into a specific piece. Now, the way this formula works is kind of the same way an average works, where you take a certain number of b's and multiply by your x1 value, and a certain number of a's, multiply it by your x2 value. Now that's going to give us a total number of things, which is b plus a. If you remember, anytime you find an average, you add up the numbers and you divide by the amount of things that you added up, in this case b plus a. And that's going to work the same for our y values. So let's take a look at what this really means in terms of a problem. In our problem here, it says a line segment AB has endpoints 5, 6, and -4, 0. So I like to kind of look at this graphically first. So let's graph out that points 5, 6, and then -4, 0. So there we go. We get a line segment like that. Now, it says that we want to divide the line segment A to B. So again, this is A here, this is B here. So that means we're starting at A, ending up at B, into a ratio of 1:2. So if you think about it, if I'm getting a ratio of 1:2, that really means I'm breaking this line into 3 parts. And so what I have to do is I have to figure out, well, how can I break this line into 3 parts? Well, if you look, there's some convenient points where it crosses here and here at those convenient lattice points. And if we look, this is a distance of down 2, so 1, 2, and over 1, 2, 3. And if you look, that same distance is here, 1, 2, 1, 2, 3. And again, 1, 2, 1, 2, 3. Now, if you notice that all those pieces are equal, do you see how this is 1 part here? So from here to here is 1 part, and then from here to here is 2 parts of the same distance. So to get that point that cuts this line to a ratio of 1:2, it would be this point right here, or the point 2, 4. So that is what we're looking for. We're looking at that point that breaks this line up into 3 equal parts, and it's broken into a ratio of 1 part to the 2 other parts. So let's look at what that kind of looks like for this equation up here. So anytime you do these problems, the B and the A come from the ratio. In this case, our ratio is 1:2. So we go A, B. So A is 1, B is 2. And then from here, and this is the important part, x1 and x2 have to kind of go in the order that the line goes in. So 5, 6 is point A. That's going to be x1 because that's where we're starting. x2 would then be the other point, -4. And then y1 would be 6, and y2 would be 0. So from here, all we need to do is put those points and this ratio into our formula. So what I like to do first, seeing as I have all these b's and these a's, I like to write out all the b's and the a's first. I'm going to go b, I'm going to leave a space for my x1, plus a, leave a space for x2, all over b plus a. Then do the same thing for my y values, b, first y value, plus a, second y value, all over b plus a. Then we just put in x1, which is 5, and we put in our x2, which is -4. Then we put in y1, which is 6, and y2, which is 0. Notice the y's went together and the x's went together. And from here, we just need to simplify this. So I have a little trick that I do to simplify this. What I do is I look at the numbers here and I say, okay, 2 times 5, that's 10. 1 times negative 4, that's negative 4. And then 2 plus 1 is 3. Then I take this a step further and I do 10 plus negative 4. Well, that's 6. And then 6 over 3 is 2. So I can do kind of all that in my head without having to take that time to type it into a calculator. And then I do the same thing for my y. 2 times 6 is 12. 1 times 0 is 0. 2 plus 1 is 3. 12 plus 0 is 12. So now I just have 12 divided by 3, which I know is 4. And hey, look at that. That's the same point we got as when we did it on the graph. So that's it. This point here divides this line segment into one part here and 2 parts here. So a 1 to 2 ratio. Alright, let's look at a second example. So in this example, we're going to do the same thing. We're partitioning the line segment, but in this problem, we're partitioning in a ratio of 3 to 2. So that means we're really breaking it into 5 equal pieces. So let's just jump right into the equation. We know that A is my first value, B is my second value in the ratio. Then I have x1, y1, and x2, y2. So all I need to do is put my numbers into the formula. And remember, I always like to do B parentheses plus A parentheses all over B plus A. Do the same thing for the y. B parentheses plus A parentheses all over B plus A. You can just go back, put in your x1, which is negative 4, put in your x2, which is 6, y1, which is 2, y2, which is negative 3. And from there, we just simplify. So 2 times negative 4 is negative 8, plus 3 times 6, which is 18. Add those together, and you get 10. And on the bottom, we have 5. So we have 10 over 5. And simplify that to just be 2. And on this side, we got 2 times 2, which is 4. 3 times negative 3, which is negative 9. 4 plus negative 9 is negative 5. The bottom here is 5. So then we have negative 5 over 5, which we know simplifies to negative 1. And that there is our solution. So let's look at what that would kind of look like on a graph. Negative 4, 2, right there. That is going to be point A because it comes first. And it says it's graph from A to B. And then point B would be 6, negative 3, right there. And then we said our partitioning point is 2, negative 1, right here. So now if we draw in a line to connect those points here, we can kind of take a look at these points here, kind of line up really nice on the line. So this is up 1 over 2, up 1 over 2. So I took 2 steps to get to that partitioning point we found. And if I look at the other side, again, same steps, 1, 2, 1, 2, 1, 2. That's 1, 2, 3 steps. So right at this point here, we have 2 steps to 3 steps, which is the ratio they wanted us to do. A to the point is 3, and then B to the point is 2. There's our 3-2 ratio. Okay, so that is all the examples for this. Stay tuned to the next video for the practice work you guys need to complete.